Hello students, welcome back to this lecture series of M.Sc. Part 1 Mathematical Methods in Physics. Okay. So in the last few classes we discussed some few important things. So let me summarize this first. Close integral over C f of z naught is equal to 0. This is one or second one. Close integral f of z naught is equal to 1 by 2 pi eta close C f of z and divided by z minus z naught dz. Okay, this is second, and third one, that is f power n z naught is equal to n factorial divided by 2 pi eta close C f of z divided by z minus z naught power n plus 1 dz. Okay, these some formulas and equations that we discussed in the last few classes. Okay, so on this today we are going to solve some question on these formulas. Okay, so let's start. This is Cauchy integral formula. This is Cauchy integral for the nth derivatives, and this one is a Cauchy-Garchet equations. Okay, so we are going to solve some example on these formulas. Okay. So first one, it is evaluate the integral close C z square plus 1 divided by z into 2z minus 1 into dz. Okay. And they given the counter, or the counter is equal to mod z is equal to 1. Okay, this is a counter. So evaluate this integral into this counter. This is a counter. So first I am going to this denominators. I write these denominators in this way: z square plus 1 divided by z into 2z minus 1 is equal to, or dz is equal to, we can write, for the simplicity I am write this denominator like this: z square plus 1 divided by z minus half dz minus z square, close integral z square plus 1 divided by this z. Okay, for the simplicity I am write this expressions like this. Okay, now we have the two terms for these integrals. Okay, so it gives the names, that is this first term, that is I1, minus second term, that is I2. Okay, okay. So now if we find the point, singular points, that is z is equal to 0 from the denominators, that is z into 2 or z minus half is equal to 0. So from this we can find the singularity points, that is z is equal to 0 and z is equal to half. Okay, so this counter is given mod z is equal to 1. Okay, so this point, this both z is equal to 0, this point lie inside C. Okay, so we can find this integrals if this is lies in inside this C. Okay, so here if I write the formula for this I1, so here we can apply the Cauchy integral formula. here is power is 1. Okay, so for that I am applying the Cauchy integral formula. So that is f of z naught is equal to 1 by 2 pi eta close C f of z divided by z minus z naught into dz. Okay, so this formula we can write close integral C is equal close integral C f of z divided by z minus z naught dz is equal to this 2 I am right in the left hand side, that is 2 pi eta f of z naught into f of z naught. Okay, so this f of z naught these expressions are right for the I1s. Okay, so let right here. Okay, from this I1 that is equal to close integral or C z square plus 1 divided by z minus half dz. Okay, so it is equal to 2 pi eta f of z naught. Okay, and this f of z naught is given, that is z square plus 2. So this 2 pi eta we can write z square plus 1 at z is equal to half. Okay, from this. So if I put the z is equal to half in this f of z, so it is 2 pi eta half half square, that is 1 by 4 plus 1 and 5 by 4. Okay, so this is equal to 10 pi eta divided by 2. Okay, this is for the result for the I1s. For this expression z square plus 1 divided by z minus half. Okay, so we want integral for this also. So let's I2 is equal to close integral z square plus 1 divided by z into z. Okay, into dz. So I2 is equal to close integral or C z square plus 1 divided by z into dz. This is equal to 2 pi eta. From the formula we can write f z naught. Okay, and this 2 pi eta, this is into z square plus 1. For the z is equal to 0 here, point a singular point, that is z is equal to 0. So this thing. Okay, because this point is lie inside this counter. Okay, so integral is equal to 2 pi eta. Okay, here is a 0 and is multiply. So I2 is equal to 2 pi I. So close integral C, that is z square plus 1 divided by z into 2z minus 1 dz is equal to I1 minus I2. Okay, this direction is opposite, that's why I am right here the minus sign. Okay, so I1 minus I2. Okay, so this pi by eta by 2 minus 2 pi eta. So this is equal to pi by 2. Okay, so 2 into 2, so it is equal to 4, and the pi by I minus 4 pi by I, so it is equal to pi by I divided by 2. Okay, this is a integral for this expressions. Okay, close integral C z square plus 1 divided by z into 2z minus 1 into dz is equal to pi by pi eta divided by 2. Okay. So it's this is for the Cauchy integral formula. Now let's see for the Cauchy integral formula for nth derivatives. Second example, closed integral or okay. So that closed integral dz divided by z square plus 4 bracket square dz and is equal to pi by 16. Okay. And counter is given z mod z minus eta is equal to 2. Okay, this is the counter, and this integral already they given pi by 16, so we have to show that this result. Okay, so here if you observe this denominator, so z square plus 4 power is here 2, or it is a square of this bracket. So here we can use the formula for the Cauchy integral formula for the nth derivatives. Okay, so first close C dz z square plus 4, these things we can okay, this is dz this thing we can write close C close integral C dz divided by z plus 2I into z minus 2 eta. Okay, like this. So now if we try to find a singular point, that is z is equal to plus minus 2 eta. Okay, so for I am just find for the z is equal to 2 eta. Okay, so this point is lie inside C. Okay, from these counters z is equal to 2 eta. Okay, so for the Cauchy integral Cauchy integral formula for the n derivative, so here f of z is equal to 1 by z plus 2 eta whole square. Okay, and from formula, that is f of z naught power n Cauchy integral formula, f power n into z naught is equal to n factorial divided by 2 pi eta close C f of z divided by z minus z naught bracket n plus 1 bracket power n plus 1 into dz. Okay, so if we observe this integral, so here is the power is 2, so okay, so this is equal to n plus 1. So if it is n plus 1 is equal to 2, so n is equal to 1. Okay, so we can find for the first derivative of this of these functions. Okay, from this n is equal to 2. Okay, so we can calculate like this n, and then we take the derivative. So f prime z naught is equal to 1 by 2 pi eta close C f of z divided by z minus z naught here. Okay, this is here I am using square dz. Okay, n plus 1, so n is equal to 1, so that's why here is a square. Now this formula we can write 2 pi eta f prime z naught is equal to close C integral over C f of z divided by z minus z naught. Okay, dz. Okay, so we are find the for this condition z is equal to 2i. Okay, so f of z is equal to 1 by z plus 2i whole square. So just I am 2 pi eta. First I am find this f prime z naught, okay, for these functions. So that is equal to f prime z naught. So I am directly write here minus 2 z plus 2 eta 3. Okay, so f prime z naught for this if we take the derivatives. Okay, so minus 2 divided by z plus 2 eta power 3. Okay, so this is equal to close c f of z close integral c f of z minus z naught dz. Now what is this f of z and z minus z naught? So if I put here, so this is equal to close c f of z is equal to 1 by z plus 2i whole square divided by z minus 2i whole square dz. Okay, so this is f of z. Okay, now this here this from this z is equal to minus z minus 2i whole square. So from this we can write here z is equal to 2i. Okay, so this is equal to 2 pi eta minus 2 plus 2 eta 3, and here z is equal to 2i. This is equal to nothing. Okay, so 2 pi eta minus 2 divided by z plus 2 eta whole square. See, if we put here z is equal to 2 eta, so here is a like this 2 pi eta minus 2 divided by 2 eta plus 2 eta cube, okay, whole square is equal to close integral over c 1 by z minus 2 1 by z plus 2 eta whole square divided by z minus z 2 eta dz. Okay, so if this 2 eta minus 2, this is 4 cube, 4 eta cube. Okay, so this is equal to 64 and this is 4. So we can write 4 pi eta, here is minus, this minus signs, divided by 64 minus eta. Okay, so this minus and this eta will be cancelled, and pi by 16. If we divide by this 4 to this numerator and the denominator, so this is equal to pi by 16. So this is our result. So we can write close integral c 1 by z plus 2 eta whole square divided by z minus 2 eta dz is equal to pi by 16. Okay, so this is what we want the result, pi by 16. Okay, so okay, let's stop here. Thank you.